All right, here we are. Welcome to Consul Community Office Hours today. We are here with I could say it's not the Consul with Lambda team, but I think it's like the Consul and everything team. I don't know how to say it. We're not going to give the official title, but anyway. Welcome to Community Office Hours. I'm your host, Rosemary Wang, and we're going to have an open Q&A with Eric and Usha from the Consul Engineering team. I also have a co-host today. Cole, would you like to introduce yourself?
Hello, world. I am Cole Morrison, one of the developer advocates here at HashiCorp. And if you've watched any of our streams, you've probably seen me before. So hi again.
I know, you're on a Consul office hours of all things, you know? All right. So anyway, as we do with office hours, if you have questions or comments, we'd love for you to interact with us in the chat. But as you do, we do want you to keep in mind your code of conduct in this virtual space. In general, be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, be professional, and just be kind. You can review our code of conduct at hashicorp.com/community-guidelines. Now, on to our office hours. I'll start with Eric and then Usha. But if you could introduce yourselves to our audience, they'd love to hear who you are, what you're working on, and what you're going to talk about today.
Hey everyone, I'm Eric Haberkorn, and I'm a software engineer working on Consul, on technically the Consul ECS team still, but it's more like the Consul AWS everything team. Usha, would you like to go?
Yes, hello everybody. I am Usha Kodali, product manager for Consul, and also with specific emphasis on AWS ECS and Lambda.
Awesome. Now, today we're going to be talking about Consul and Lambda. If those who are not as familiar with Lambda, I know Usha is going to provide a bit of an overview. Eric's going to go a little bit into it as well. But could you tell us a little bit about Lambda, right? Why would you want serverless to be part of a service mesh? What's so interesting about adding a serverless function to the mesh? I know you have some slides. Let me know if you want me to just start with your slides and then we can take it from there.
Yep, go for it.
Okay.
All right, so here's our intro slide that Rosemary, you already introduced. So today we're going to talk about what is serverless in general, and then we're going to zoom in a little bit and talk about what is AWS Lambda, why should we care about it? And then we're going to talk about how we adopt Lambda, how do we integrate it with existing runtimes? And then we're going to talk a little bit about what is Consul, and then we're going to talk about how Consul can solve the Lambda adoption and integration problems that we will have introduced earlier in the talk. So next we're going to move on to the what is serverless part. Usha, would you like to go ahead?
Yeah, sure. The next couple of slides I could walk through. So what is serverless, and why is serverless so important these days? And there was a really nice, cool meme. It actually showed about a server, and serverless is basically a ghost version of a server. So where you don't really see the server, but there is a server in the back end. So that is serverless. But what does that really give to the end user? It's really the ability to run your application or even code function as a service without really having to manage any of the servers at all. So there is no cost for your infrastructure management, and also it actually, the next slide actually talks about why it is so important. Why is serverless important? What is that you really get by not managing the servers on your own? One, it definitely saves time because you're freed up instead of having to manage all of those, and you have less operational overload because you don't have to waste your resources on managing the servers. If there is a CVE, you don't have to worry about upgrading that. And reliability, you get reliability is based on the organization or the cloud platform which is offering these servers. So they ensure that the system is reliable at all times. And you do get security, but security is a shared responsibility. There is security of the cloud and security in the cloud. So there are some aspects of security that the end user would still have to take care of. And we will see how Consul plays in that role. And there is security of the cloud, for example, upgrade of the OS version or the CVEs that I just mentioned. Things of that nature would come for free, not certainly for free, but you do pay as you go. And also you do get the scale to zero, like from nothing, you can scale up to whatever the system would allow you to. And also you pay for usage, and it's not like a continuing recurring cost that you would have to incur upfront cost, and also the resources that you spend to maintain these. And why do we have to do all of these things? Why is serverless so important? Yes, it does all of these things. Number one, it increases productivity. So I would say productivity is one of the key for serverless. Eric, do you want to go into, serverless adoption? Yes, we have seen serverless. I believe AWS Lambda, particularly the function as a service, was introduced in 2004. And since then, serverless has been not just for AWS Lambda, in general, serverless adoption has been increasing. And there is a latest survey done by Datadog, and it reports that the mainstream adoption has increased over 50%. What does that really mean? So all of the workloads that are on the cloud have at least 50% of that cloud adoption is on serverless. So that is huge. And this is based off of 2022 report. And when we talk about serverless, there are also two things that we'll have to consider. There is serverless containers, which is little different than function as a service, where it is even overly simplified. You just run your function as code. And serverless containers, where you would still have to worry about bringing your own OS onto those containers. And the market size for serverless, because there is such a need, and the estimate is that it's going to grow over 22.7% at CAGR, that's the compounding rate of 22.7%, and it's going to reach about 21.1 billion by 2025. We can find these in different market research. So they're all around the same numbers, 20 to 28% of CAGR. So serverless adoption is really increasing, and now you'll see why we should really care about serverless and the use cases.
Awesome, sounds good. So now that we have an overview about what serverless is in general, let's zoom in and talk about AWS's implementation of it, or one of theirs, and that is AWS Lambda. So Lambda is a serverless computing platform that AWS made. It's function as a service. And so you give Amazon a bunch of code and they're responsible for running it. And so what attributes does Lambda have? So billing is per millisecond. So you pay for exactly what you use and nothing more, unless you really care about sub-millisecond billing. And Amazon is also responsible for scaling. So if there's a bunch of invocations of a Lambda function, it'll scale way up. And then as soon as those invocations go down, it will automatically scale down, and you'll only pay for exactly what you use. And like all serverless things, there's no need to manage servers. So before we get into the challenge or the goal of our talk, let's talk about the history of different runtime platforms. So not very long ago, let's say 20 years ago, 15 years ago, or less for some organizations, most people are running things on premises. They had their own data centers. They managed everything themselves. And then people started moving to cloud. And typically in the cloud, things run on virtual machines. So let's say 5 years ago, container orchestration became popular with Docker Swarm, Mesos, later on Kubernetes. And now we're starting to see serverless adoption. And what I'm trying to get at here is that everything is changing. Just 5 years ago, how many of us use Kubernetes? Now, how many of us are using it? And if it's not Kubernetes, then maybe it's ECS or Nomad or something like that. And so even if you and your company don't need serverless now, things are changing. And so leaving options open is something that we should all consider. And that, like, from an architectural perspective, having options is awesome. If you can defer decisions, that's great. That's a huge win. So we're going to move on and we're going to talk about our challenge or our goal. And our challenge is to integrate AWS Lambda with another runtime. So for the sake of this conversation, we're going to use Kubernetes since it's relatively popular. So now so the challenge is we have a service running on Kubernetes and we want to invoke a Lambda function. How do we go about doing it? All right, so one way that we can do it is we can use an AWS SDK. And so this requires changing the code within the calling service to use the AWS SDK. You have to construct the Lambda client, you have to invoke the Lambda function, and everything just works. Or does it? There's a few additional things that need to happen. So the first thing that needs to happen is the service has to have IAM credentials available. So this means that where the pod is running, it has to have credentials running. I believe the SDK picks up the credentials from EC2 metadata automatically. So the role that it is running on EC2, it'll also pick it up from ECS metadata or environment variables. And the other thing that we have to take on in order to use this approach is we have to take up a dependency on the AWS SDK. So the calling service needs to know that the Lambda actually is a Lambda. So this is the burden that's put onto the calling service. Another way that Lambdas can be invoked is with function URLs. And this is the way that AWS recommends invoking Lambdas via HTTP. And so there's two different ways that Lambda functions or that function URLs can be protected by auth. One is none, and the other is with AWS IAM credentials. With none, this means that the Lambda is open to be invoked by anyone who knows the URL of the Lambda function. So this means that the auth needs to be done within the Lambda function's code. And this is possible. It's not that difficult to do, but potentially if this auth code happens and it takes too much time, it requires database calls and things like that, that means that all of the concurrency across an entire AWS account can be saturated, and potentially this one public function URL can end up causing an incident across all Lambdas in an entire AWS region. So this is problematic. It's also tricky. It's also easy to do the wrong thing. And so for the sake of argument, since we're talking about calling from one service to the next, AWS IAM provides another approach, and that's exactly like we described before. The calling service needs to have the ability to, and it has to have the permissions to use the function URL to invoke the Lambda. This requires signing the request, and it requires having the credentials. The way that requests are signed with function URLs is using the SIG v4 format, which it's possible to do in different ways, but a common way of doing it is just with the AWS SDK. And so even when using function URLs, there are a couple of challenges for the team that owns services that invoke Lambdas. They have to have IAM credentials, and they have to sign the request. So just to dig in a little more on these challenges that are more or less shared across using the Go SDK and function URLs. So in either case, IAM credentials need to be available. On AWS, it's possible to use EC2 metadata, ECS metadata. Outside of AWS, if you want to invoke a Lambda function, you can do it in a couple ways. You can do it the worst practices way of having long-lived credentials running somewhere, or you can create temporary credentials and continue to rotate them with Vault. Then as for signing requests, the team that owns the Lambda, maybe they can make a client library and they can abstract this away and they can just say, call the Lambda function through this library, or else they'll have to say, use this SDK. This will work. And so this requires the team owning the service that calls the Lambda to know that the Lambda is actually there. So let's go back to our goal and say, our goal is to integrate AWS Lambda functions with other runtimes. Are these approaches good enough? So if we would take this to an architectural review board and we would say that we're putting all of these burdens that we just talked about onto the code owning service, I can see architectural review boards or whatever it is in your company saying, that's a little bit too much. So we're going to move on and we're going to talk about Consul, and then we're going to finally move on towards the end of talking about how the Consul can help solve that.
Eric, I have a quick question for you, just up until this point, just for my own clarification. So thus far, thank you for the full overview on Lambda and everything, but it seems like the main point, because we're getting through here, I'm like, when we get through this, I'm supposed to like want to go and take all of my microservices and start adding Lambda to them. But what you've pointed out is that there's a lot of overhead that we're going to incur if we want to take this current approach. Specifically, we're going to have to take every one of these services, we're going to have to modify them to work and add these Lambdas into our architecture. And that is what, okay, just making sure. Awesome, thank you.
Yeah, exactly. I'm trying to point out the complexity of doing this currently. Yeah. And then we're going to move on to talking about how the implementation that we built into Consul ends up making things easier.
Perfect. Thank you so much.
Awesome. So before we go on, let's talk about the way that Consul works. So with the service mesh architecture, each service that runs has a sidecar proxy that runs next to it. In the case of Kubernetes, it runs in the same pod as a sidecar. In ECS, it runs in the same task, and so on. So whenever a service makes a request to another service, it actually ends up making that request to its local sidecar proxy that forwards the request onto the sidecar proxy of the other service that finally sends the request on to the destination service. These sidecar proxies are configured by Consul. And so Consul, let's say this service, named service, it registers foo as an upstream, meaning that it's a service that foo is allowed to call. Consul knows that foo is an upstream, and so the sidecar proxy, Consul gives it configuration, and in Consul it uses Envoy as its sidecar proxy. Envoy is configured to know where foo is running, and all of the routing rules around that are kept up to date over time. So now we're going to go on to talk about some cool attributes that we get out of this sidecar architecture, because there's definitely some overhead, and so there's got to be some benefits in order for it to be worth it. So Luke Kaisau and I presented at HashiCorp Europe recently. We gave a talk about the multi-runtime capabilities of Consul, and we deployed HashiCups, which is a sample coffee shop app, to AWS, Azure, and Google Cloud, and we used Kubernetes, ECS, Lambda, Nomad, and VMs. And so we demonstrated that this gives us multi-runtime capabilities. For the sake of this demo, we don't have a chance to go into it, but I recommend that you all check that out to see just how helpful Consul is for multi-runtime and multi-cloud use cases. So another thing that we get out of Consul and the service mesh architecture is that we get awesome observability benefits. These sidecar proxies automatically keep track of metrics around all of the requests that go through them, and they end up in Prometheus. And so you don't have to instrument either the calling or the destination service with these metrics. They just exist for free. And they exist in a format that's uniform, and so you don't have to worry about service calling a metric one thing and foo calling it something else. You can easily make unified dashboards around that. Another benefit is around security. Consul provides TLS certificates to all of the sidecar proxies, and these proxies are used to create MTLS connections between services. And we'll get to this a little bit more in the demo, but this is awesome from a security perspective. Another thing that we get out of it is traffic management. This is a pretty simple use case, but if we update Consul saying that we want half of the traffic that's meant to go to foo version 1, and we want the other half to go to foo version 2, then the sidecar proxies for any service that calls foo will automatically update it just to send half of the traffic to each of the services without service, the calling service, needing to know anything. Are you all following me?
Yeah, so in summary, basically, in order for, well, the way Consul Service Mesh works is that there's proxies for every service.
Yep.
And your expectation is that you would have a proxy per service. But I imagine this is, you're getting to this, but what happens with Lambda? It's not like you can run a proxy with a Lambda, right?
Yep, exactly. So there's a bunch of constraints about Lambda. Like, for example, Lambda doesn't validate, it doesn't allow you to do MPLS connections to it. And there's weird things like you have to have the IAM credentials available when you make a call to a Lambda function. So it's weird. It doesn't follow the normal service mesh architecture. And so when we were building the ability to call from mesh services out to a Lambda, we had to take these into account and solve for them. And so it's a different type of integration than other ones.
I'm guessing we're getting ready to dive into it.
Yep, exactly. Exactly. It was the perfect question because the next slide starts getting into that. So recently, just a few weeks ago, we released the public beta of the ability to call from service mesh services out to Lambdas. And we did this. There's a couple of different ways that you can do it. One way is that just from the normal sidecar proxy that runs next to a service, as long as it has the IAM credentials available and it's configured correctly, it has the ability to invoke the Lambda directly. So what this solves for is it solves for the request signing or the credential, the request signing or the SDK being a part of the service itself. At this point and with this workflow, the calling service doesn't need to know that the service is running on Lambda, but the credentials still need to be available so that the sidecar proxy, Envoy, is able to invoke the Lambda. So this approach, as we talked about, it has one limitation that IAM credentials need to be available on each of the pods or tasks or whatever that are running the services. This gets pretty complicated because service 1 might call foo and bar, service 2 might call foo and baz, and so on. So each service needs its own credentials, and when you're using least privilege, which we all should be, it gets complicated to manage all of these rules. So what we recommend is invoking Lambdas through terminating gateways. This means that the calling service, the sidecar proxy is automatically configured based on Consul's configuration to invoke the service as a Lambda, and the IAM credentials also aren't there. The IAM credentials live on the terminating gateway. And this works with another feature that we will be getting to in a little bit, which is intentions. So intentions use the TLS certificates that we talked about before to validate that against a set of rules. And they say, hey, sidecar service 1, it's allowed to call foo, but not baz. And so if service 1 tries to invoke baz, the terminating gateway will receive the request. Its Envoy proxy that's running the terminating gateway will be configured with rules that say, nope, if I receive a request from service 1 to baz, we're going to drop it and we're going to return an unauthorized error. So we get the same zero trust story out of this that we all love for using Consul and service meshes in general. But things are much easier to manage. So now we have it so that service 1 doesn't need to know where foo or whatever Lambda it's trying to invoke is running, and it doesn't have to have IAM credentials. So we've actually solved both of those challenges that we talked about earlier.
Very, very nice. Can I ask a quick clarification question, Eric? So the original, so everything, obviously, we know we've talked about service mesh goes through proxies. The first main issue was going through a proxy out to a Lambda. Initial draft of work would be to just give the proxy the IAM credentials, but as you saw, that's a bit messy, especially if we're trying to do least privilege access for any of these given roles. So putting a terminating gateway, which you can almost think about, this is obviously not one-to-one accurate, but you can almost think about almost like another proxy for your proxies to go out to Lambda. It is just the thing that knows where the IAM credentials are instead, so that we don't have to. Yeah, so this goes back to the whole thing that I asked you about earlier of like, now I got to go re-architect everything. This makes it a lot easier. Nice.
Yeah, exactly. So now, based on what we've talked about before, the calling service doesn't have to have credentials on it, and it doesn't have to know that the service it's calling is even running on Lambda. So at this point, the calling service doesn't care where the service is running. It could be running on ECS, Kubernetes, wherever, Lambda. It really doesn't matter. And so it takes a lot of burden and cross-team collaboration, which, as we all know, takes time. It gets rid of the need for that, and it just makes a Lambda just another service.
Nice. Now the painstaking learning process that Rosemary introduced me to learn terminating gateways, it's all coming full circle. Thank you,
Happy
Eric.
that you learned it now. There's a question in the chat, and
Yep.
I guess just to clarify, are you saying the outbound calls to a service, which is actually a Lambda function, will spin up a Lambda function on its own? I don't know if the Lambda function is in reference to the terminating gateway or some other mechanism, but if there is an answer to that, Eric.
Yeah, so this gets a little bit into the inner workings of Lambda, but the gist of it is that when a Lambda is invoked, it automatically spins up if there isn't one running and there isn't capacity available. There's two ways that you can start a Lambda. One is that it's just initialized from scratch, and the other is that it can be unfrozen. So Lambdas, when they run and they're not called for a while, they're put into a frozen state, and so they can quickly be started up the next time they're invoked. And then automatically Lambda, when it receives a call, will restart up or unfreeze that environment. So those are the two of the ways. There's a third or fourth that Lambdas can be spun up. But those are the main ways.
Thank you. I think actually the question that Cole raised also answered the original question too, but it's good to hear about the different ways that you can invoke Lambdas and how this is at least relates to adding a service mesh to it. I think we're good on questions for now. Shall we demo?
Awesome. Yeah, sounds good. So we're going to do the standard demo that every Consul and HashiCorp demo seems to use, and that's HashiCups. HashiCups is an online platform for ordering coffee. You can check the coffees out, add them to your cart.
I'm just going to put a disclaimer. These are not real coffees, and we don't actually want your credit card information. You will not get a coffee if you order from here. I just wanted to add a disclaimer.
Nice, thanks for that. And it gives it away that there's an autofill for credit card credentials. That's probably not a feature we should build. But basically it ends up giving the ability to look at coffees, order them, add them to your cart, buy them, all of that sort of stuff. And so what we are going to do is we currently have this architecture. We have a front-end service that makes calls to an API that's running GraphQL, and that makes calls to a products API that depends on Postgres, and then there's also a payment service. So we have a really, really over-architected coffee shop that it really does fit a modern microservices architecture. And what we're planning on doing is we're planning on saying, nope, we don't want the payments app to be running where it's currently running, which is on Kubernetes. The team that owns it wants to move it to Lambda, and we're going to demonstrate just how easy that is. So if you look here, if we look at our last order, we can see it says encryption disabled, and this means that within the payment service, let's just pretend that within its database, there's no encryption running. It's plain text. We're storing credit card numbers. We're violating all sorts of regulations. We're going to motivate this whole entire thing by wanting to move to a new payments app that's storing everything in Vault. And we're talking about everything about the data that's being stored within databases rather than the network traffic. because Consul will ensure that all of the network traffic is using MTLS connections. And so we actually don't have to worry about encrypting these connections. Yeah, so the next thing we're going to do, we're going to try to start getting rid of the payment service. So the first thing that we need to do is we need to register the Lambda into Consul. This requires registering a service into Consul's catalog and creating a service defaults configuration entry. It's not too much work, but it's an annoyance. And so we've built a service called Lambda Registrator that automatically does this for you. Lambda Registrator runs on you guessed it, a Lambda, and it's triggered by event bridge events. These event bridge events happen whenever a Lambda is modified. So when it's created, updated, deleted, tagged, untagged, and those types of things. So whenever these events happen, Lambda Registrator is triggered, and then the Lambda is synced into Consul. So we're running everything on this EKS cluster. If you look here, we have our pods running, and then we can look here and we have all of these services running. So you can see here we have the payments app, but we don't have a payments app that's running within Lambda. So I already deployed a Lambda function called Lambda Payments that we're going to use within our Kubernetes cluster as the new payments app. The way that Lambda Registrator gets triggered to sync a service into Consul is with this enabled field. When this field is set to true, which we can do right now, it triggers Lambda Registrator. Lambda Registrator sees that this service should now be registered into Consul, and then it automatically does that registration. So now here is our Lambda Registrator. You can see here that it's triggered by Event Bridge. And then when we go over to the monitoring tab, we can go to the CloudWatch events. And then hopefully we will see an event within these logs that shows that the Lambda was registered into Consul. I'm not seeing it there. It looks like it ended up making there. So I am going to assume that I'm looking at the wrong logs and move on. So awesome, let's go back to our slides. So we registered our Consul. The next thing that we're going to do is we're going to register the Lambda payment service to a terminating gateway. If we look here, we can see that no services are linked to the terminating gateway. So when we go and we apply our configuration, and I'll show you what the configuration is actually. It's a normal terminating gateway configuration entry with Lambda payments set as one of the services. So if we look back in the UI, it looks like we have to refresh. We can see that now the Lambda payment service is triggered, which means that every single time a Lambda payment service is invoked or is called, that those calls will go through a terminating gateway. So let's go back to our notes. So the next thing we're going to do is we're going to update an existing service to include Lambda payments as an upstream. So we will go to, and we're doing this just to make sure that everything works end to end before we actually start rolling things out. So here's our public API service. And we'll trigger it with to run on port 1234. We'll apply the configuration. And then we'll watch while this rolls out. So we have a new pod starting up here. And so we just have to wait a second.
So while we wait, I did post a link to the Terraform module for the Consul Lambda Registrator. Is there, I guess, a separate cost to creating and using, let's say, like Event Bridge for the registrator?
Yeah, it's not very much. I can't tell you an exact amount, but we we did some calculations, and using Lambda Registrator for even a pretty big use case, if I recall correctly, it's like 1,000 Lambdas. It's like a couple bucks a month. Cool. So it's not very significant.
Yeah. So if anybody is using the module, just know that, yes, it is spinning up other components, and you will have to take those into consideration if you're very much conscientious of your Lambda invocations and cost.
Yep.
Yeah.
Yep.
And also to know that is not the only way to register. So definitely that will ease up the way to register automatically, but certainly the user can manually register all of the Lambdas into Consul directly. There's a manual way to register as well.
Awesome. Thank you.
Awesome. So now the next thing I did, now that the new public API pods have rolled out, is I just started a port forward so I can locally call this new Lambda service. And then we'll do this, we'll curl on localhost 1234, and uh-oh, we got an access denied error. What are we gonna do? Nothing's working, we're sad. So this gets back to the intentions thing that we talked about a bit before. So each of the certificates that Consul distributes uses the SPIFFE specification. And a part of the SPIFFE specification is something called a SPIFFE ID that looks like this. When the terminating gateway receives the certificate, it says, it validates if the certificate is properly signed by the correct authority, and it also has a set of rules that check to say, can the public API service invoke the Lambda? If not, return this. And so we can go within the Consul UI under intentions, and we can see we have a default deny intention. And so how do we give the ability for the public API to invoke the Lambda payment service? This is all we have to do. We have to say that when making calls from public API to Lambda payments, allow it. So now if I try this out again, it might take a couple of times. We get this only post is supported error, which actually is the right thing because I'm not calling it correctly. See, this is the code of the actual Lambda payments function. And so it actually is working correctly. So we verified that at least calls from the public API to the Lambda payment service are working correctly. So the next thing we're going to do is we're going to actually start rolling traffic out. Before, all of the traffic was going to the existing payments app. Now we're going to use a service splitter, which right now we're using for a simple use case, which is just sending half of the traffic to the old payments app and half to the new one. It can be used for a lot more complicated things that are out of the scope for this discussion. So all I have to do to use a service splitter is I have to apply it. And you can see it's the exact same thing that we just looked at. So now if I port forward on the actual port that the public API is listening on, we can start testing out the same requests that it actually receives. So now we can test it a couple of times and hopefully we see requests of both type. So as you can see here, before it was saying encryption disabled, meaning that at rest or within the database, there's no encryption. And now we can see that this returns encryption enabled by Vault. And so we can be happy to see that it's working and we can move on to fully rolling this service out. So all we have to do to fully roll this service out is we can change this 50 next to the Lambda payments to 100%. And then go back to the HashiCorp's user interface, add a new connected Chino to the cart, check out, and we see encryption enabled by Vault. So now we've fully shifted all of the traffic over without modifying public API's code at all to go from calling the old payment service to the new Lambda payment service. We did all of this without touching public API's code. This could theoretically happen without the public API code owning team even knowing, but that sounds a little bit scary. But this is a really cool benefit of the service mesh architecture and running all of these proxies. The last step that we'll leave for another day would just be shifting all of the traffic over in a more permanent way. But we did what our goal was. We shifted from invoking hitting a service that's running within Kubernetes to invoking Lambdas without the public API having to know that the service is running on Lambda or having to do anything complicated like that. So just as a review, we're using function URLs as an example here, but it's the same type of argument for using an AWS SDK. So here we have simple IAM credential management. This is something that Consul gives us that we don't get via function URLs. No code changes required by the calling team. This is something that Consul also gives us. And Lambdas are just another mesh service. As we saw here, Consul also gives us this. And then we also have the other service mesh benefits, which are observability, traffic control, security, and so on. And these are all things that everybody gets out of using Consul, whether it's for Lambda or not.
Eric, you mentioned that Consul treats Lambda as another service. Do you want to just talk about how that is? Because these Lambda functions are ephemeral. And for Consul to really do routing, it actually relies on health checks. So in this case, how does Consul take care of Lambda as part of the service mesh?
Yeah, so I guess I'll answer a slightly different question before moving on to that. So the sidecar proxies, as we talked about before, are running Envoy. And within Envoy, it has the ability to configure a service or a listener, to use actual Envoy terminology, as a Lambda function. And so Envoy supports Lambda out of the box. And so health checking. So with the way that we do it is we just assume that a Lambda is always healthy, because there's not really a good way to health check a Lambda. With like a Kubernetes service, you'd make a route that you use for health checking to say, is this pod healthy or not? With Lambda, it's not really possible to do anything like this without triggering the Lambda itself. But what we can do, and it's something that Envoy supports out of the box, is passive health checking through outlier detection. So if a service is calling a Lambda and there's more than a certain number of 500 response codes or broken invocations, then Envoy can, if the proper failover rules are properly set up, fail over to a different service. And so outlier detection, just to use a more standard term, is just a circuit breaker.
Cool. We actually have another question in chat, and I do want to address it before you go to the summary, but the IAM role attached to the mesh gateway, which I think it means terminating gateway. So the IAM role that's attached to the terminating gateway, does it have a Lambda invoke, or can we specify each Lambda arm that we want Consul to invoke?
Yeah, so it needs to have permissions, the Lambda invoke credentials for all of the Lambdas that are invoked through it. And so what I would recommend is when a new Lambda service is deployed, the terminating gateway's permissions are updated to allow it to invoke that Lambda. And then in conjunction with that, you can narrow all of these credentials down, essentially scoping it down for each of the calling services by having a default deny permission. And so even though the terminating gateway has permission to invoke that Lambda, none of the services can actually invoke the Lambda until intentions are created for the service that is eventually calling out to the Lambda.
So basically, oh, sorry, go ahead, Cole. No, okay, all right. So basically, the intention, you're shifting the more granular definition of the specific Lambda function that the calling service needs to use to an intention instead of an AWS IAM credential or IAM policy.
Yes, exactly. And so for users of Consul, you automatically get this for free because it's the way that permissions are done between any service within Consul.
Cool. And I guess in the another question, because we talked about a calling service accessing Lambda, but what about the reverse? What if a Lambda needs to call a service in the mesh?
Okay, I can take that. So that is something that we are looking into, and based on feedback, we will see to address that use case in the coming months. But that is of interest to us as well.
Cool. I mean, could you use something like an API gateway if you're on Kubernetes or the Ingress gateway in order to do this today? Or are there other considerations and challenges that would prevent us from doing this today?
Yeah, I can take that. So doing that is definitely possible, but doing it in a way where it has first class service mesh support is a bit challenging. In that with a service mesh, you want to have MTLS. Like that's a pretty fundamental thing with Consul service mesh. How do you go about doing that? How do you go about making sure that intentions work? How do you go about making sure that a lot of the mesh services, the mesh benefits end up carrying over to these services? It ends up being pretty challenging.
Awesome. Yeah, that's good to know. Okay, I don't think we have any other questions coming into chat, so I guess we could wrap up, and then if there are any other questions from Cole or some of the other folks, we'll give it a couple minutes.
Awesome, sounds good. So the last thing we have is a quick summary. So we started about talking about what is Lambda and serverless in general. We talked about why it's important. And then we moved on to talking about the goal that we had of this whole talk. That's we have a service and we're wanting to integrate Lambda with an existing runtime. And so we have a service that's needing to invoke a Lambda. And how do we go about making that as easy as possible? We then moved on to giving an overview of Consul itself. And then we talked about how the integration that we built between Consul and Lambda makes things a lot easier when you have an existing runtime and you're wanting to invoke a Lambda function.
Very cool. All right, I'm going to take your screen share away, Eric. Sorry. That way we can go back to full view. I think that there was a fantastic overview. I appreciated the use of HashiCorp, but also the payment service. I think it's more, in some ways, it's probably more practical that it was a Lambda. It was like we almost wrote it as a Lambda. I don't know, or we intended the function to be a Lambda. Cole, do you have any other questions? I know there may or may not be questions trickling in the chat, so let me know if you do have questions. Please put them in the chat. This is our last call.
Yeah, I just want to, it's sort of a question / clarification again, which is just painting the scenario for me as an ops person that may be on something like EKS or any of these other different container runtimes that I can pair up with Consul. One of the things with the service mesh, if you're using alternatives, is being stuck inside of Kubernetes, right? And so with this gives me the ability to start offloading stuff to Lambda while still not putting really much of a burden at all on the service maintainers, because it's all going to go through this terminating gateway. And in addition, it also seems like it's going to take some of the load of IAM off of us, because we're going to be able to centralize the Lambda IAM to one place as opposed to going through it and doing it piecemeal. And we'll just be able to continue our flow that we have with our service mesh already, which is using intentions and the like within Consul to manage the Lambdas. This all sound on point. Yeah. Yep. Okay.
Sounds good.
Yeah. I guess my one question is, because earlier Rosemary went to ask you a question, and I almost asked kind of the same question, and that is just your thoughts and your strategies around that IAM management aspect in terms of you have one terminating gateway reaching out to who knows how many Lambda functions. Is there any point in time where you would want to split that and maybe have separate? Would there ever be a reason for that, to make it so that different terminating gateways have like more restricted permissions? Or is that something you wouldn't care about since you're going to just do it all in intentions after the fact?
Yeah. So it would be possible to run multiple terminating gateways, but we also we allow both approaches actually. So if a customer doesn't want to run a terminating gateway for this, we actually do provide the ability to invoke Lambdas directly from sidecar proxies. And this automatically happens if you don't have a terminating gateway, if the Lambda services aren't registered to that gateway, it's just automatically invoked from the sidecar. And so whatever customers want to do, we actually do support it.
Nice. It's like one of the best answers, right? All right, cool. Thanks, Eric.
No worries.
Oh, so wait, so that works with intentions too, as well?
That does not work with intentions. That's one of the only four terms.
And would transparent proxy have to be turned off in order for that to work? Okay.
Yes.
Yeah. Okay.
Yep.
So for those who are familiar with Consul and are familiar with how it works on Kubernetes, if you were to do this on Kubernetes, you have to make sure transparent proxy is turned off, or you have, I suppose, an outbound exclusion. Is that what some kind of outbound exclusion to the invocation, the function URL, if that's the situation. I'm just reading chat. So it sounds like Eric recommends using a deny rule for the IAM role attached to the gateway, deny invoke capabilities on the Lambda unless it has the Consul tech. Excellent. All right, any other questions from folks? If not, then I think we're going to close it out today. This was really awesome. Thank you so much for showing us and explaining to us all about Lambda, as well as how it works with Consul. I'm really excited to hear how this continues over time. If anybody has interest in learning more, you're welcome to check out the announcement for the public beta of Consul Service Mesh support for AWS Lambda. You can give it a try. Where should folks reach out if they want to offer feedback, or they have additional interest, or they have comments?
I think GitHub's probably the best place. Like, ask us a question if it's a ticket or.
Actually, we do have a feedback form. I believe in the blog, towards the end, there is a feedback form. So we would be happy to receive feedback, and if interested, we could schedule a call with the user to have like a 15-minute conversation.
Awesome. Well, thank you, Usha, and thank you, Eric, for joining us today. We appreciate you taking the time out to explain this and prepare such an awesome demo. It's really exciting. For those who are joining in and you're new, we do have other office hours coming up. I believe we'll have one on Boundary. And stay tuned for HashiTalks Build, which is tomorrow. I think tomorrow, and it's tomorrow? Yeah, it is tomorrow. And the day after that, you'll find it on the YouTube channel, as well as some other our other channels as well. So you'll hear a lot of different talks across many different products and tools from the community. It's a great opportunity to get to know a lot of the different tools and experience the community. With that, thank you very much for joining us today, and we'll see you on the next community office hours. Bye, everyone.